Hello, and welcome to this episode of EPRI Current. I'm your host, Bill Florence. Today's episode is all about renewable wind energy, focusing on wind turbine technology. We're going to talk with three experts to update us on this technology, with a particular focus on some important projects underway in Europe. Curtis, Nikolay, and Clément, welcome to EPRI Current. Let's start with some brief introductions. Curtis, since you're one of our very first sort of return guests on EPRI Current, why don't you go first?
Yes, thank you, Bill. My name is Curtis Fox, and I lead EPRI's offshore wind research and development portfolio. And under that, we cover everything from grid integration to wind turbine technologies to environmental aspects of offshore wind. And we utilize a lot of subject matter expertise around EPRI to support this research and development. And we're happy to be here today to talk with you about some of these unique projects.
Great. Nikolay, why don't you go next?
Thanks, Bill, and hello, everyone. I am Nikolay Dimitrov. I'm a senior scientist at DTU Wind Energy, the Technical University of Denmark, and I work in applied statistics, data science, reliability, and we do collaborate with EPRI in several activities.
And last but not least, Clément.
Thank you, Bill. Hi, everyone. I'm Clément Jacquet. I'm a senior researcher here at EPRI. I focus mostly on wind farm optimization. I have around 10 plus years working in the renewable energy. And my focus at EPRI, I act as a tech leader for all our activities in Europe. So performance diagnosis of the wind farm is my biggest chunk of work, but I also focus in reliability modeling, maintenance forecasting, and cost modeling for the wind farms.
Great, thank you. Curtis, let's jump right back to you. What's sort of the status of global offshore wind development, and how are offshore wind targets driving the industry, and where is offshore wind advantageous in being deployed?
Yeah, so obviously you need to have a coastline to deploy offshore wind. But, the unique aspects associated with decarbonization plans, resource, water depths, and load centers all play into, how offshore wind is being deployed in certain regions around the globe. But it is totally a global effort now. There's been some challenges in the industry to date, right? The macroeconomic challenges that we've faced in the U.S. and Europe and other regions, right, have kind of driven up the cost of commodities and challenged the industry, since it is a little bit of a capital-heavy energy form. But global targets, they've expanded a lot over the past 10 years. And we've got, as of 2023, we had 75 gigawatts of installed capacity globally. We're looking at 2030 targets of over 350 gigawatts. And then we look farther out, projections are the largest ones we've seen are close to 2,000 gigawatts of offshore wind. Now that's going to require a mix of technologies we've deployed today between fixed bottom and looking at the future floating offshore wind that gets us out into deeper waters, but where there's more consistent wind resources. So there's a lot of unique challenges that we're facing in the industry, and so research and development will help.
Nikolay, can you maybe add to that? Maybe from a European perspective?
Some challenges in Europe are very much similar as the ones in the US, which include the economical challenges, like how much it costs to install wind farms offshore. But there's also additional challenges due to, for example, having some spaces where a lot of offshore areas are developed, and then it means that wind farms may interfere with each other. So there's some wind farm wake interactions. That's one thing. And also the other thing is the electricity market, which is being influenced by the high level of influence of renewables. So that's some interesting challenges where having a lot of wind and solar in the system and the grid actually affects significantly the electricity purchase prices.
Excuse me for interrupting, but did you say wake to wake there a second ago, or
farm to farm? Yes, okay. There's wake from one farm to another.
Is that the physical, like the waves wake, or is that like an air turbulence of some sort?
That's the air wake. So the goal of the wind turbines is to extract energy from the air, which means that basically they slow down the wind to some extent. So behind the wind farm, there's a wake where you have a smaller wind velocity and less energy because you have extracted some of this energy, which means that if you have another wind farm nearby, if the wind direction is unfortunate, then you'll get less power output from the second wind farm, which is nearby. So these type of considerations are also part of the entire puzzle when you need to develop a new project and find out what's the best layout and where to place your wind turbines. And in addition, another thing that you want to do is how do you produce power? What time and how do you feed it to the grid? If you know that at some point, if it's very windy, then you may have less income than if it's less windy, for example.
Exactly. Curtis, I mean, Nikolay identified some of the challenges that maybe we may be facing in trying to reach some of these targets. I mean, which seem to be extremely aggressive. I mean, if we're going, I think you mentioned like going from like 75 to like over 300 something. I mean, what are some of these maybe some additional challenges that you're seeing in order that will have to be overcome in order to reach offshore wind's potential?
Yeah, Bill. So if we set aside maybe some of the differences between floating and fixed bottom and really just focus on we're generating wind in the ocean, there's a number of risks that come up and challenges that come up. The number one priority for the industry is reducing the levelized cost of energy. It is a very capital intensive form of energy. It has an extensive OPEX on having to carry on operations in the ocean. But it does yield a better LCOE than onshore wind due to the fact that it has a higher annual energy production. So you put all that together, driving down the cost is key. And how offshore wind's been able to mature is, rapid adoption of new technologies. We've seen turbines scale up in size. We've seen new cable designs. We've seen new substructure designs. We've seen optimization across the supply chain to be able to help this. But when you introduce new technologies, you introduce new risks, new uncertainties into the market. And a lot of the research and development that we're looking at is looking at how to manage and handle some of these risks. And the HIPERWIND project is a great example of how we've been able to apply some new philosophies and tools to manage those risks. But being able to take these new technologies, we take them into the fold of the supply chain, mature them quickly, is instrumental for us to be able to industrialize this offshore wind effort and really build out the capacity we need to, look at 350 gigawatts by the end of 2030, right? And 2 terawatts by the end of 2050. Those are big targets.
And obviously, I mean, research and development is key, to addressing some of these things and looking at, I guess, new opportunities to move forward, correct?
Yeah. There's a lot of space for research and development. There's the farm-to-farm interaction. There is, as well as, all across the life cycle, right? So EPRI's research spans all across the life cycle of a wind farm, particularly an offshore wind farm. And we look at that. There's opportunities for informing design practices that we use today, right? With lessons learned and experiences we've developed with our first 75 gigawatts being deployed, wrapping that back in and changing how we evaluate and look at data. We look at design practices, how we improve reliability forecasting of the equipment, and how we develop, digital tools to really help us sift through a lot of the information we have now is one of the key challenges we have in the industry. And so research and development that allows us to take all of these inputs and our future targets and new technology and be able to kind of mash them together, but focus that on building a more reliable, more resilient power plant is key for the industry to move forward.
And one of the key sort of projects in this area is this HIPERWIND project that's really sort of European centric. And Nikolay, can you explain the HIPERWIND project and some of its goals and some of the outcomes that either have been achieved or maybe that are hoping to be achieved here in the near future?
Certainly. HIPERWIND is an EU-funded project, so funded by the European Union Horizon 2020 program. It ran for 4 years. It just finished a month ago, so we are now wrapping up the latest results, and I think we already have achieved quite some interesting outcomes. First, I want to mention the word uncertainty and risk, which Curtis also mentioned as part of the challenges we're facing nowadays. So this is really also the key area of focus area for HIPERWIND. When we have uncertainty, we are being penalized somehow for the lack of knowledge, because imagine if you don't know something, then you want to put some safety. And this applies both to the materials, but even to things like interest rates and insurance premiums, where any kind of perception, even it's not necessarily a real probability of something happening, it's just the perception of risk already makes you have to have higher costs. And so understanding uncertainties, which is a major driving factor in risk, is really key here. So in the HIPERWIND project, we really focused on understanding the uncertainties into the offshore wind turbine design modeling chain, and trying in each step of this chain to try to quantify these uncertainties, find ways to deal with them, integrate them into the design process, reduce where possible, and also see how this can be utilized to get better design and reduce the overall risk. So some particular things we focused on is starting from the environmental conditions. We wanted to see how to characterize those in a better way, then see how this affects further down the design chain, looking at loads, looking at how these loads further affect the turbine reliability, annual energy production, and in order to be able to somehow find out if all these parts of all these modeling efforts lead to some positive impact, then we also want to do some impact assessment, and which is actually one of the major parts where EPRI was also involved, trying to find with cost modeling on whether any other modeling development we've done in HIPERWIND, if it had any impact on the final cost of energy. So some brief outcomes. I think we found out that first, taking uncertainty into account in itself, that's very important, because you understand your design problem better. So you really then find out what are the parts where you don't have enough knowledge, or maybe you need to improve your models. That's one part of it. Then we also saw that actually just doing a very simple thing, doing integrated design, so doing all parts of the turbine, or trying to dimension all parts of the turbine and the substation, the foundation and substructure together, yields better results than taking each of these parts and designing or optimizing separately. Other things we found out is there was a lot of different software tools and methodologies we developed, and I think many of them are worth by themselves, or working with them by themselves. And overall, based on the entire, let's say, work and all the combined effort, we were able to reduce the levelized cost of energy. We estimate somewhere between 5 and 10%, which is quite reasonable. And we hope that this is somehow going to impact also future designs, the future ways of making design, and also the future ways of understanding how big are the risks in different parts of our design process.
Clément, I promise I haven't forgotten you. But can you talk a little bit about EPRI Europe's contributions to this work with HIPERWIND, and maybe some other the technologies that are taking place at this point in time?
Sure, Bill, thanks. Yes, so our involvement in HIPERWIND was to quantify the impact of the other technologies on the LCOE, that metric Curtis mentioned a bit before, just that quantifies how much dollars you need to put in so that you can produce 1 kilowatt hour or 1 gigawatt hour of energy with the technology you're considering. So it's kind of basically a critical task in the project, because it's defining whether we have delivered what we have promised at the beginning. So we've write this proposal, then incredibly smart people worked for 4 years on that, and we arrive at the end and we gather all those inputs and we try to quantify and justify that the gain were achieved. And it's also kind of challenging, because what Nikolay was mentioning, we were starting from the wind at the beginning, up to the design of the turbine, up to the operation of the turbine, and how every small changes on that process impact the overall cost in the end. And also, how do you factor in uncertainties with that? So we had kind of developed tools and methods just to be able to go into the detail of a specific component, what is the reduction of what impact does have the reduction of the mass of the tower, on the overall cost of the wind farm integrated over the lifetime, but also considering the entire design, the estimation of the annual energy production over the lifetime. So really taking a lot of inputs, mashing them together into a metric that makes sense in the end. I think, as Nikolay mentioned, it's kind of a successful project in the end because we were able to deliver a substantial amount of LCO reduction. So meaning that the technologies that were developed through this project actually pay off and pave the roads towards a more reliable and cost-efficient offshore market. But it also helps us understanding what are the pain points that remain and where we should focus our work for the next research.
Clément, we focused on the HIPERWIND project, but there's other projects that are taking place over in Europe as well, right? I mean, that complement HIPERWIND, and maybe you're looking at some other advances in technology.
Definitely, HIPERWIND is not the end of the story. I think it was a really exciting project, and there's definitely, now that we have completed it, we were definitely smarter than what we were at the beginning. But as what Curtis was mentioning at the beginning, and just if you look at the scale, how offshore wind needs to ramp up in the years to come, and the challenge that remains, we still have a lot of things to do, and we are at EPRI contributing in other projects where what we learned in HIPERWIND will be definitely put into contribution. There is this wind twin project, which is about developing digital twin for offshore wind farms, with the goal of providing decision maker with an online tool to inform them and take informed decision for strategic choices. So how do you define a wind farm? How do you adjust that wind farm? How do you find the best layout, turbine model, maintenance strategy for a given location? And how do you compare across different scenarios so that you're sure that you actually take the most of that wind farm? So in that part, EPRI will also focus in the maintenance optimization part. And we will leverage our internal knowledge on turbine reliability and our internal database, but also the tools and methods that we have developed into HIPERWIND are a direct fit into that project.
Isn't there another project? I mean, Twain, like as in Mark Twain, the American writer, but I mean, is that also one of these new projects, or complementary projects that's taken place?
Yes, this is another project which DTU is currently coordinating, and where the main focus is on integrated wind farm control, but there's several of the same problems that we need to work with, again, talking about uncertainty and about the effect of loads or environmental conditions on the lifetime of the turbines. And there we are definitely using several of the HIPERWIND developments, including some of the reliability tools, finding out if you decide to control your turbines otherwise, how will it affect the reliability and the lifetime of the turbines. And something which I probably will say a few times today is that the software tools are always very valuable outcomes, because that's a very easy way to replicate or to use your results in other setups. So you can reuse a lot of the work you've done by creating tools that also can be used by other people.
These findings from HIPERWIND and Twain, and then the twin piece, I mean, these are all findings that can be used by the industry wherever it is, right? And can be incorporated into the industry's future plans. Is that correct?
Yes, I think that's very fair to say. I think it's really what we want to see is making the technology accessible. So lowering really the bar, I think, is something which can ensure wider adoption by industry. So really, if you make sure that others can use the tools easily and like say as a plug and play feature, then I think that's very useful, because this really makes it, if it's so easy to use a tool, then it's something that you may use and you may be inclined or ready to use. So in that sense, I would think that let's say the user friendliness and the possibility to have these tools available, like accessibility, is something which can make it so much easier for industry to work with and adopt. And there's also a few particular outcomes I think I would warmly recommend for others to use. And this is, for example, this finding of using integrated design. So designing the entire system as much of it as possible together in one go. I think that could lead to some significant improvements. And then there's a few research gaps also, I would imagine. The clear research gap to me is that we didn't focus too much in material properties. And they may also have, let's say, a part of this uncertainty and part of the risks. And so that's probably something where I would imagine industry should, or we should look into future projects. In addition, other future activities I would be also personally interested in pursuing is looking at the data science and uncertainty assessment as something to make decisions under uncertainty. So not only finding out what is the current state, but also trying to find out what is the best, let's say, the best strategy to react. For example, if you see certain operating conditions and situations.
Curtis, let me bring this back to you now. If you can, maybe discuss a little bit about how EPRI is taking and maybe leveraging these technologies that were developed in HIPERWIND, and maybe looking at maybe expanding those onto a broader scope, in some form or fashion.
I think it's important to realize that while we're talking a lot about generating wind offshore, there are regional differences throughout the globe that drive different decision-making processes in the offshore wind design process. And so, not just understanding those differences is key, but also understanding how to take assumptions that go into a wind farm design, maybe in Europe, and how that translates into the US or into the Asia Pacific region, right? And what are the differences of how that energy will integrate into the market and the onshore grid? And, in certain areas, offshore wind may become a dominant form of energy there, right? And so understanding the reliability and the resiliency of that offshore wind and how to optimize it for the regional capture are key. And so, I view HIPERWIND is a basis point, a jumping off point that challenges us to look at the status quo or how we've built the industry to date, take a step back and go, what have we learned? How are we able to apply optimizations, probabilistic design better to this and reduce that uncertainty that Nikolay talked about and really reduce that cost? And so it's not a one size fits all solution. It's a tool that then gets moved to different regions and adapted to the uncertainties and the technology that needs to be deployed in those regions. So, when we look at how we can impact with a broader scope, it's a basis for us to start that discussion. But it will have, carry on research that'll build upon that and be able to deploy better solutions and more optimized wind farms to better integrate and ultimately reduce this whole LCOE concept and allow us to meet our targets, meet our objectives in a clean and efficient way.
Curtis, that sounds like a great sort of wrap up. But let me just ask. Nikolay and Clément, any maybe final closing thoughts from either of y'all?
I think it's a certainty we all agreed how important it is. And also in HIPERWIND, we've had a really deep dive into understanding those uncertainties and trying to find ways into integrating them in our thinking and way of designing turbines. But to me, it is still a very complex task. So I think still there's a lot of more to do. And also some of the, maybe as a wrap up, we have learned how to deal with uncertainties, but I think we can do more in terms of also simplifying this process and finding out how to also make it more, make sure that all this information can be more accessible in terms of better tools, simplifications, or trying to summarize our results and our main conclusions into something which can be more deployed in a broader sense. And I think that's something we could definitely work more on. But that's only 4 years we have in the project.
Great. Clément, any closing thoughts from you?
Yeah, I just want to highlight, kind of synthesize a bit, I think what that was kind of all the way through that discussion, kind of the complexity and the need for an holistic approach, like considering the entirety of the system. Like offshore wind is probably compared to onshore, I guess it's the turbine is just a small part of the total infrastructure. Like you need to put those turbines at sea, you need to operate in an harsh and predictable environment. And so, there are many complex aspects that needs to be accounted for. And if we want to make offshore wind succeed, we need to get good at all of those, and we need to kind of prioritize where the impact will be maximum. And one of the learning I take from HIPERWIND is really like this: when you consider the entire design chain from the beginning to the end, this is where you can deliver the maximum value. So that's still a huge task lying ahead of us, but I think it's exciting in terms of challenge, and we have now tools and methods that we can apply to make offshore wind better and more reliable.
Thank each of you so much for sharing your insights and expertise on these projects in today's show. For your listeners, if you'd like to learn more about today's topic, we'll include links in the video and in our show notes for you to get some more information. I hope that you'll join us again. Please subscribe to our podcast, leave feedback or review. Tell us what you'd like to learn about in future episodes of EPRI Current. As always, please share today's episode with your colleagues and friends. That's it for this episode of EPRI Current. I'm Bill Florence. We'll see you next time. If you like today's show, we invite you to subscribe to our podcast. And feel free to share the podcast with your colleagues and friends. For more information about EPRI, please visit our website at www.epri.com. And don't forget to follow us on LinkedIn and Twitter at EPRI News. Together, we are shaping the future of energy.